time division multiplexing was first developed for applications in telegraphy, to route multiple transmissions simultaneously over a single transmission line. In the 1870s, Emil Baudet developed a time multiplexing system of multiple Hughes telegraph machines. TDM is a method of transmitting and receiving independent signals over a common signal path, by means of synchronized switches, at each end of the transmission line, so that each signal appears on the line, only a fraction of time in an alternating pattern. TDM is the digital multiplexing technique. In TDM, the channel link is not divided on the basis of frequency, but on the basis of time. Total time available in the channel is divided between several users. Each user is allotted a particular time interval, called time slot, during which the data is transmitted by that user. Thus each sending device takes control of entire bandwidth of the channel, for fixed amount of time. In TDM, the data rate capacity of the transmission medium should be greater than the data rate required by sending or receiving devices. All the signals to be transmitted are not transmitted simultaneously. Instead, they are transmitted one by one. Thus each signal will be transmitted for a very short time. The TDM system can be used to multiplex analog or digital signals. However, it is more suitable for the digital signal multiplexing. TDM works in synchronized mode. Both ends, multiplexer and demultiplexer, are timely synchronized, and both switch to next channel simultaneously. When channel A transmits its frame at one end, the demultiplexer provides media to channel A on the other end. As soon as the channel A's time slot expires, this side switches to channel B. On the other end, the demultiplexer works in a synchronized manner and provides media to channel B. Signals from different channels travel the path in interleaved manner, or at different time slot. You will learn two types of time division multiplexing in this course, which are synchronous TDM and asynchronous TDM. In synchronous TDM, each device is given same time slot to transmit the data over the link, whether the device has any data to transmit or not. Each device places its data onto the link when its time slot arrives. Each device is given the possession of line turn by turn. If any device does not have data to send, then its time slot remains empty. Time slots are organized into frames, and each frame consists of one or more time slots. If there are n sending devices, there will be n slots in frame. Disadvantages of synchronous TDM. 1. The channel capacity cannot be fully utilized. Some of the slots go empty in certain frames. As shown in figure, only first 3 frames are completely filled. The last 3 frames have 6 empty slots. It means out of 24 slots in all, 6 slots are empty. This wastes the capacity of links. 2. The capacity of single communication line that is used to carry the various transmission should be greater than the total speed of input lines. It is also known as statistical time division multiplexing. Asynchronous TDM is called so because, in this type of multiplexing, time slots are not fixed. The slots are flexible. It ensures the link is well utilized, and does not go empty. In terms of speed, asynchronous TDM is faster compared to synchronous TDM. Here, the total speed of input lines can be greater than the capacity of the path. In synchronous TDM, if we have n input lines, then there are n slots in one frame. But in asynchronous it is not so. Advantages of TDM. 1. Full available channel bandwidth can be utilized for each channel. 2. Intermodulation and distortion is absent. 3. TDM circuitry is not very complex. 4. The problem of crosstalk is not severe. Disadvantages of TDM. 1. Synchronization is essential for proper operation. 2. Due to slow narrow band fading, all the TDM channels may get wiped out.